Hello everyone, today we are looking at our second type of transformation and it is called a translation. Actually, it's called several things. So you can call translation slides or glides or of course translations, and I'm going to call them pretty much all three of those to try to get you used to those terms. We're going to look at a particular way to translate to slide or glide a figure using what are called vectors. Now, this might remind you of a quote from a certain popular movie where vectors are determined or defined as a quantity that has both direction and magnitude. But in order to know what that means, we got to look at a couple vectors themselves so we can see what we're doing with them. Well, when we take vectors, what we're trying to show people is how to take a point and move it to its new location. And since we're doing a slide or translation, we're literally sliding it down a line. And that line that we're sliding it down is the vector. Vectors are usually written as then an arrow with an endpoint and a pointy end, of course. And with these, we're going to use a notation that will label the vector with a letter, similar to what we do with a line. And we put a little notation mark on top that kind of looks like an arrow, but it's missing the bottom part. And they took that bottom part of the arrow off because they want it to be distinct from a ray, which uses an arrow for its notation. But notice how these vectors work. I've moved C to its new location, C prime, along that vector. I did the same thing with A here. It slid down that vector to get its new location, and the same thing with B. It slid that vector all the way down to B prime. And in order to use a vector, you have to be aware of how it is going to move that object. It's going to move that object in a certain direction, and that direction can be determined by looking at the degree the vector comes off of a horizontal line. So here I can find my direction by just figuring out what degree am I going. And if you extend this line, you see that we are going at about a 30-degree angle. So our direction is 30 degrees up from horizontal. On the other hand, you also have a magnitude. A vector will also include not just that direction, but how far you go. And it will just be the length of the arrow that is indicated by that vector. In this case, I can measure it. And I see that this is about 4.5 centimeters long. So my 4.5 centimeters is my magnitude. That means that just given an arrow, I can do any translation because that arrow provides the necessary direction and magnitude to slide my figure. So let's go ahead and try that out with this translation using the vector P. In order to do this translation, I'm going to have to find the direction I'm going in for each point, and then I'm going to use the magnitude to find where my new point moves to. I'm going to start by just labeling my original figure, and I'm going to call this figure, well, let's go with bat. And since I want to translate according to this vector, I have to figure out what direction I'm going in. Now, like I said, you can take a horizontal line and measure the degree that you're going either up or down from that horizontal line. There's actually a bit of a shortcut here, though. If you move very carefully, you can actually just use the original vector, so I can see it's coming at this degree, and slide my ruler super carefully so it remains parallel to that original vector. And I will then have the direction correct when I sketch in a line down here. So you can see I have slid it down as carefully as I can so it remains parallel to the original. And I will repeat that step with each of the points so that I am sliding each point along that same direction as this arrow is sliding them. Now, once you have your direction worked out, you have to account for the magnitude of your translation. And magnitude, again, can be found by taking the vector that you're working with and measuring it. So I'm going to measure this one, and I find that it is about, well, that looks like almost 2 centimeters, just slightly under 2 centimeters. It's like 1.98 centimeters, really, really close. And so what I'm going to do is at each one of these, I'm going to go down to that same length, and that is where my points will move to. So A slides down until it hits here, which is A prime, and B slides down that same distance, and so on and so forth. Now, once you have translated every single point, you can connect those points to finish up your figure. If you've done this correctly, what you're going to get is an image in which the new lines, like A prime, B prime, are going to be parallel to the original. So these two will look like they are parallel. They'll also be the same length as the original because nothing in the figure will change besides its original location. If you find that your figure is distorted, let's say that one of my points T prime ended up way down here instead of where it was supposed to be, and my final image was this kind of messed up, lopsided triangle that didn't look like my first, well, I can clearly see that those lines are not parallel. Like, this is not parallel to my original. So something went wrong with one of those points. And I can go back and I can fix it because I can see that my figure got distorted. But otherwise, my original was correct. So I'm going to just shade that in so it's easy to see, and I will call it good. Anytime we're working with rulers, though, and protractors, there is quite a bit of inaccuracy that can go on. So what we're going to do is we're going to learn another way to work with vectors, and that is on the coordinate plane. Coordinate plane, fancy way of saying graph. So a vector can be used on a graph as well, and here we use a vector to move from point A to point B. And notice it's just an arrow. Well, on graphs, a lot of times we talk about movement, or those arrows, as a horizontal and a vertical shift. So I've gone over 6 and I've gone up 4. That over 6 and up 4 is actually our vector. And what we're going to do is we're going to record vectors as a vector coordinate. They get pointy little things instead of parentheses because, well, vectors are pointy little things. They're arrows, they're movement. So don't forget pointy little things, not parentheses. And what you're going to do is you're going to tell people how to move horizontally. You're going to move positive 6 over. And how to move vertically. You're going to move positive 4 up. Well, this means that anytime you have an original point, like in this one, our original point was A, 2, 3. I will add my vector to that original or initial point to get my final point or my terminal point. Notice here that what you are adding is your x's on this side, 2 plus 6 to get the point 8. You can see I am at 8 for x. And your horizontal or your vertical component, y, you add those, 3 plus 4, which gives you 7. And that results in 8, 7, the point B. And we can use this idea to either find a vector given a transformation or to take an image or pre-image and shift it around into its new image. So let's try both of those real quick. If I want to find the vector v that translates the original pre-image ABC onto the image A prime, B prime, C prime, I have two options. I can either draw the path that this took horizontally and vertically and record what I got. So I get 1, 2, 3, 4 over in a positive direction towards the right, and 1, 2, 3, 4, 5, 6, 7, 8, 9 down, so that's going to be a negative 9. And I can get my vector that way. I move 4 over, 9 down. That's one way to get our vector v that translated the figure. However, we don't always want to count, and sometimes we don't even have everything graphed, so you might just be given your initial point and your terminal point and be asked to find the vector. So what do you do in that case? Well, don't forget that you have an equation. You know that your initial point, let's take an initial point A where we have negative 6, 1. If you added your vector to that, which we know is going to be 4, -9, but let's just pretend we don't know what that is right now. If I added that to it, I should get my terminal point, A prime, which, if I look at the graph, is -2, -8. And all I have to figure out is what did I add to get to -2. So -2 minus -6 gives me an answer of 4. So my terminal point, or I'm sorry, my vector has an x component of 4, because 6 plus 4 is equal to, or -6 plus 4 equals -2. I can do the same thing with my y. 1 plus what is equal to -8? Well, -8 minus 1 gives me -9. So I know that my vector would have to be 4 or -9 in order to move from A to A prime. So you can solve it using that method as well, and it's really up to you as to which one you want to use. Of course, we don't just want to find vectors, we want to use them. And again, you have both of these methods to choose from. You can either use the graph itself, or you can do a little bit of algebra. So if I wanted to use vector coordinates to find my image, what I can do is I can look at the vector they provided, and they're just usually going to drop an arrow on here. Sometimes they'll give you the vector coordinate along the side, but a lot of times they just throw an arrow on the graph and say use that vector. Look at how you move from the starting point of the vector to the end. And in this case, we have 2 over 3 down. That gives us the vector coordinate to -3. I can then go to any point and I can move 2 over and 3 down to find my new point. So C moves 2 over 3 down, A moves 2 over 3 down, and B moves 2 over 3 down. And that already gives me my new figure. However, sometimes, again, this is not going to be the easiest method to use, because maybe you're dealing with some really large numbers, or you don't actually have a graph, you just have the coordinates to work with. Well, don't worry, you can still use your vector coordinate. I could take my original C point, add the vector coordinate to it, and I should get where C prime is as my answer. So let's look at the original C. That is at the point 0, 1. If I add my vector coordinate to it, I get 0 plus 2, which is 2, and 1 plus -3, which is -2. And so my C prime should be at 2, -2. And if I look, I go 2 over, -2, down, so that gives me my C coordinate, and that is accurate to what I found earlier. And that's how you guys can use these on a graph. That is all I have for you guys today with terminal points and vectors. Check out Classroom to see your homework.